Last little bit of section 1.7. I'm going to actually change one word on here because I don't know why it bugs me. So it says reflections in the coordinate plane. So reflections in the coordinate axis of, or in the coordinate axis of the graph y equals f of x are represented as follows. Reflection in the y-axis, I prefer the word over. So reflection over the x-axis. What we're going to do is we're going to take h of x and we're going to take the opposite of all of h, or f of x. Whatever function f of x was going to be, we're going to take the opposite of everything. Number two, if we're going to do it over the y-axis, so again, I'm going to change it instead of in, I'm going to say over h of x, we're going to do f of the opposite of x. So we're only going to take the opposite of the x's, just the x's, each and every x. So using the parent quartic function f of x equals x to the fourth, we're going to use that to write the equations for the following graphs. So the one on the left, it's an upside down quadratic, or an upside down quartic, I should say. It looks like it's upside down, but it's also a little bit higher, because typically, if you recall what a quartic graph looks like, it looks something kind of like this. So that's not the best, but it's not the worst. So we're going to say a couple different things. We're going to start off with x to the fourth. And I'm going to make a quick table out of this. And then we're going to transform x to the fourth. Let me make that a little bit better. We're going to transform x to the fourth in a couple different ways. So this function here is going to be upside down, and it's going to be up a little bit higher. So one step we could do is reflect it over the y, or over the x-axis. Over the x-axis, there we go. So by starting by reflecting over the x-axis, what we're going to do is we're going to do negative x. Oh, I'm sorry. I miswrote that. We're just going to put a negative in front of it. Negative x to the fourth. So reflecting it over the x-axis, we're just taking the opposite of everything, which in this case is only the x to the fourth. Now we also have to shift it up a little bit. It looks like it's been shifted up by 2. So using what we did at the top, we're going to just take what we have currently. We have negative x to the fourth, and we're going to add 2 to it. So based off of what we see here, we could say g of x equals negative x to the fourth plus 2. Again, this time the negative is not in those parentheses. So it's the opposite of x to the fourth plus 2. There is another way you could do this, and that way would look a little something like this. In my opinion, what we just did is probably the easier option. But we're going to take x to the fourth, and we could actually start by shifting it down by 2, which should give us x to the fourth minus 2. Then after that, so that'd be step 1, after that, we could reflect it over the x-axis. So just like we did in the previous one, but now we're doing things in a different order. So if we reflect it over the x-axis, what we'd end up having to do is take the opposite of all of what we just had, x to the fourth minus 2. So when we distribute that negative to both, you'd end up with negative x to the fourth plus 2. So the same way, just in a slightly different order. For the one next to it, h of x. H of x looks like it's been flipped over as well. Let me zoom in on this. Looks like it's been flipped over as well and been shifted a little bit to the right. So that's your right in this case. So starting off with x to the fourth, this one, the order is not going to make a huge difference. So what we can do, and I'm going to say, let's just flip it first. So I'm going to say reflect over the x-axis. So same as we did the first go around for the other one. So we're just going to make that negative x to the fourth. Now we're going to shift it to the right by, looks like 1, 2, 3 here. So we're going to shift it to the right. And in order to do that, we have to put that in parentheses with x. And remember, horizontal shifts always seem a little bit backwards. Even though we're going to the right, we're actually going to be in the function subtracting 3 from it. Oh, no, sorry, not squared, to the fourth. So we're going to say h of x equals negative x minus 3 raised to the fourth power. Again, in this case, for the shifting right and the horizontal or the reflecting over the x-axis, doesn't matter which order you do it in. You'll end up with the same thing either way.